Assalamu alaikum dear students, I am Ms. Sada Bahar, your physics teacher. I hope you all are fine. Albert Einstein once said that, learn from yesterday, live for today, hope for tomorrow. The important thing is not to stop questioning. Well, dear students, we have finished Unit 10 in the last 2 weeks. Today, in our presentation, we will start Unit 11, Sound. In Unit 10, we discussed all types of wave in general, and now in Unit 11 we will discuss sound as mechanical and longitudinal wave in nature. The contents of Unit 11 are mentioned on the first page of the presentation. Dear students, in Unit 11 our today's topic is 11.1, Sound waves. In this topic we will discuss about the production, propagation and nature of sound. So to proceed towards the topic, first of all, learning objectives of the lesson. Learning objectives: at the end of the lesson students should be able to write the answers of the questions given in the start of the presentation. Dear students, we will discuss here that how sound is produced and propagate with the help of some examples. Sound waves, like other waves, sound is also produced by vibrating bodies. Due to vibrations of bodies, the air around them also vibrates, and the air vibrations produce sensation of sound in our ear. For example, in a guitar, sound is produced due to the vibrations of its strings. Our voice results from the vibrations of our vocal cords. Human heartbeats and vibrations of other organs, like lungs, also produce sound waves. Doctors use stethoscope to hear this sound. Conditions: the necessary conditions for the production and propagation of sounds are a vibrating body, some material medium, such as air, water, solid, and receiver-like ear. Question: with the help of an experiment show that sound wave is produced by a vibrating body. Answer: experiment. In school laboratories, we use a device called tuning fork to produce a particular sound. If we strike the tuning fork against a rubber hammer, the tuning fork will begin to vibrate. We can hear the sound produced by tuning fork by bringing it near our ear. We can also feel the vibrations by slightly touching one of the prongs of the vibrating tuning fork with a plastic ball suspended from a thread. Touch the ball gently with the prong of a vibrating tuning fork. The tuning fork will push the ball because of its vibrations. Now if we dip the vibrating tuning fork into a glass of water, we will see a splash. This splash is due to the vibration produced in the prong of the tuning fork. Conclusion: from this experiment, we can concluded that sound is produced by vibrating bodies. Question: how can you prove the mechanical nature of sound by a simple experiment? Answer: mechanical nature of sound. Sound waves require some material medium for their propagation. This can be proved by bell jar apparatus. The bell jar is placed on the platform of a vacuum pump. Experiment: an electric bell is suspended in the bell jar with the help of 2 wires connected to a power supply. By setting on the power supply, electric bell will begin to ring. We can hear the sound of the bell. Now, start pumping out air from the jar by means of a vacuum pump. The sound of the bell starts becoming more and more feeble, and eventually dies out, although bell is still ringing. When we put the air back into the jar, we can hear the sound of the bell again. Conclusion: from this experiment, we conclude that sound waves can only travel or propagate in the presence of air. Longitudinal nature of sound waves. Propagation of sound waves produced by vibrating tuning fork can be understood by a vibrating tuning fork. Before the vibration of tuning fork, density of air molecules on the right side is uniform. When the right prong of tuning fork moves from mean position O to B, it exerts some pressure on the adjacent layer of air molecules and produce a compression. This compressed air layer in turn compresses the layer next to it, and so on. A moment later, the prong begins to move from B towards A. Now the pressure in the adjacent layer decreases, and a rarefaction is produced. This rarefaction is transferred to the air layer next to it, and so on, as the tuning fork moves back and forth rapidly. A series of compressions and rarefactions are created in the air. In this way, sound wave propagate through the air. Conclusion: the above experiment shows practically the longitudinal nature of sound waves. Review questions with answers. Question 11.5. Sound is a form of wave. List at least 3 reasons to support the idea that sound is a wave. Answer: as wave of any type can reflect, refract, and diffract. Same 3 phenomena, that is, reflection, refraction and diffraction, can also observed in case of sound waves. Question 11.6. We know that waves manifest phenomenon of reflection, refraction, and diffraction. Does sound also manifest these characteristics? Answer: yes, sound also manifests the characteristics of waves, that is, reflection, refraction, and diffraction. It means sound is a form of wave. For example, echo is the practical example for the reflection of sound. Listening of the person in other room is an example of diffraction of sound waves. Refraction occurs when sound travels from warm air into cold air. Well, dear students, at the end, I would say to you all, take care of yourself and stay safe. Thanks.